lush forests and green valleys, out in the middle of the Sahara. Sounds a little crazy when you think about it. However, according to a 2018 study, we can do just that by adding solar panels to the world's largest desert, the Sahara, which combines for a grand total of 3,600,000 square miles. To put that size into perspective, the United States and all of its territories are a total of 3,796,742 square miles, which puts the Sahara at roughly 94% the size of the United States. Or another way to look at it is that it would take 13.4 states the size of Texas to make one Sahara. And it doesn't stop there, as among many things, there are multiple challenges when it comes to traversing the continent that are even greater than here in the United States and North America as a whole, as there are no direct routes across the middle of the region. For example, you can take a 51-hour drive to go from San Diego, California, all the way to New Brunswick in Canada, for a total of 3,379 miles, which is a relatively straight route across the North American continent. However, if you wanted to go straight from Dakar, Senegal, to Cairo, Egypt, which is a similar distance of 3,260 miles, well, you would be a little out of luck, as the center of this region has very few, if any, roads that traverse these latitudes. Instead, you would have to take an 87-hour, 4,605-mile journey through the coastal roads of Africa that cover about 7 countries, 8 if you include Western Sahara. So the ultimate question here is how do solar panels turn this desolate desert environment covered by sand dunes and some inland mountains into a lush, beautiful Amazon-like rainforest? Well, as it turns out, it's very much possible and not unprecedented in the history of Sahara for it to become green like the rainforest, as it had been once before and will be green once again in about 15,000 years, all because of a natural occurring process called precession. Now, you see, the Earth doesn't just revolve around the Sun, it wobbles when it does so, and it does so over a period of thousands of years, which changes the angle that the Earth points itself towards the Sun as it continues its wobble over eons, thus forcing changes in Earth's climate. Now, instead of waiting thousands of years, we can change the albedo of the surrounding area relative to the current environment. And if we look at the chart here, we can notice that an albedo of 1 would be highly reflective and albedo of 0 would be highly absorbent. Now, if we look further closer into the image, we can see surfaces like snow and clouds and ice being highly reflective, while surfaces like soils and deserts and forests being highly absorbent. And this includes solar panels, which have a relatively darker surface relative to its environment. According to the article here, that cites a 2018 study on this matter, both of which the article and the study I will include in the link below, states that only about 15% of solar energy that is actually converted to electricity using solar panels, which sometimes can be as high as 22% depending on the source and the type of panel you use. Now, of the solar energy converted into electricity, this energy includes visible light, infrared, and ultraviolet. The rest is dissipated into heat, which in this case would create a temperature differential between the land and the ocean, thus creating low pressure zones that would force a higher evaporation rate from the surrounding ocean, which this in turn would lead to higher condensation and a higher rainfall in the region, thus spurring more of the Amazon-like vegetation that we are hoping to achieve. So voila! There you have it. We have a green Sahara. All good. Now, if you've watched any of my videos before, we can't get too far ahead of ourselves, can we? Because there's almost always a catch. The first is that it would take a monstrous effort to cover about 20% of the Sahara's surface to achieve this effect. Now, doing some quick math, this comes out to covering a land area of roughly 720,000 square miles, or 1,968,000 square kilometers for those of you that are watching from Europe. Hello. Or about a land area of 3 states the size of Texas, or covering almost over the entirety of the state of Alaska with panels as far as the eye can see. A truly gargantuan solar farm. So now that we have the land area figured out, we need to do the next part, and probably the most important part, figure out exactly what we need and how much we need of it. So to do this, I decided to use a standard LG 370 watt panel to accomplish this task, which with each panel being about 67 inches in length with 40 inches in width, or about 18.61 square feet. So, to cover 720,000 square miles of land, we would need, and get ready for this, approximately 1,078,519,661,660.5 solar panels. With each panel costing about $810 per panel, this would cost us approximately $873,625,945,945,080.10. Almost a quadrillion dollars. Quite the number. On the plus side, this would generate 399,052,274.8 megawatts of energy, or enough to power the United States 852 times over. That's a lot of juice, and realistically, you don't need to go that hard at it. However, we still have to face our second problem, which ironically is climate change. See, forcing such drastic changes to the local environment, you cause changes elsewhere. Our good friend conservation always finds a way. In order to gain something here, you have to give up some energy elsewhere. And the more it falls, the more rainfall you get in Sahara, at least according to this study, you will have less in Amazon and Central America. So you're effectively taking forests from one continent and adding them to the next, as based on the models shown below. The only way to mitigate this is probably to go full terraform mode, which we are not yet capable as we are not a tier 1 civilization, and we would have to start using an immense amount of energy to start pumping water into mountains and valleys from the oceans and then desalinate it on the way up. A truly crazy and expensive process. So there you have it, folks. This is my quick and dirty guide to simple terraforming. All you need to do is generate a ton of energy, have 10 times more money than the entire global GDP combined, and be driven enough to achieve your dream. Now, interestingly enough, this article is more of a thought exercise than a real matter of concern. However, it is interesting because the values I present, I feel, are kind of the values you have to start thinking about when it comes to mega engineering projects in regards to global terraforming, especially when you start considering projects outside of this Earth, such as terraforming Mars. It would literally start costing you this much to do so. Now, if you made it this far, I love you. Thank you for tuning in. Really appreciate it. Now be sure to like and subscribe, and I will post all the links I used from my research in the descriptions below. Have a great day. Hope you learned something, and I will talk to you later.